Hi, and thank you for your question. For this question, what we're doing is we are balancing this equation, this reaction. And we have calcium nitride combines with water to create calcium hydroxide, which is a compound containing a polyatomic ion, and NH3 is created. When we're balancing, one of the techniques is to keep together compounds that have polyatomic ions. And you can see here that, or keep together, sorry, the polyatomic ion, which is right here, the OH. That's your polyatomic ion, the hydroxide. That is true if hydroxide occurs on both sides of the equation. If it doesn't occur on both sides of the equation, then you don't keep it together. So because this hydroxide is not found on this side, and H2O is not the same as hydroxide. OH is one oxygen to one hydrogen. Water is two hydrogens to one oxygen. It's a different ratio, so don't mistake water as hydroxide. So if hydroxide was on both sides, then I would say keep that polyatomic ion together, but as it's not on both sides, then we're just going to separate the oxygen and the hydrogen. So I'm going to go ahead and show you how I balance this. First of all, I'm going to piece out all of the elements in the product and in the reactant. So I have calcium, I have nitrogen, I have hydrogen, and I have oxygen. And I'm going to leave the balancing of hydrogen and oxygen to the very end because that is one of the methods when you're balancing equations to leave hydrogen and oxygen to the end. It makes balancing a little bit easier. And I should have the same elements on either side, the product side and also the reactant side. My next step is just to tally up how many of each I have. So calcium, the subscript is 3, so I have 3 calciums. Nitrogens, I have 2. Hydrogen, I have a subscript of 2, but I have, sorry, that coefficient of 6 isn't supposed to be there. We'll just take that out. I have 2 hydrogens there, and I have 1 oxygen. Okay. On this side, there are no coefficients, so I don't have to worry about that. Calcium, I have 1. That 2 pertains to each of the elements inside the brackets. So I'm going to have 2 hydrogens here, plus the 3 hydrogens here for 5 altogether. If you want to, you could put a 5. Some students like to tally them up separately. So 2 hydrogens plus the 3 hydrogens here equal 5, just to remember that they are separate. I have 2 oxygens there, and my nitrogens, I have 1. So that's the first major piece, is making sure that you have your tallies right for each of the elements on both sides of the equation. Now I'm going to go ahead and balance my metals first, then my nonmetals, and then my hydrogens and my oxygens. So calcium is my nonmetal. I have 3 on the product side. So I'm going to put a 3 here to balance out the calcium. That's going to give me 3, but that's also going to change my O and my H numbers. So I will now have 2 oxygens times 3. That's going to give me 6 oxygens altogether. And then 2 hydrogens times 3 is going to give me 6 hydrogens here, plus my 3, which will give me 9 altogether. Okay, so 2 hydrogens times 3 is 6, plus 3 is 9. So that coefficient of 3 balances my calciums for now. Next, I'm going to balance my nitrogens. I have 2 here. I'm going to need to put a 2 in front of this. That changes my nitrogens to 2. This also changes my hydrogen count again. So I keep my 6 over here. 2 hydrogens times 3 is 6. Plus 2 times 3 is another 6. So now I have a grand total of 12 hydrogens after balancing my nitrogens. So my nitrogens are now balanced, my calciums are balanced. Lastly, I have to do my hydrogens and my oxygens. I'm going to do oxygen first just because there is so much going on here with my hydrogens. I have 6 oxygens on my reactant side, so that means I'm going to put a 6 here. That will balance out my oxygens at 6, and 6 times 2 hydrogens give me 12. That balanced out my hydrogens just by balancing out my oxygens. So that is the final balance to get this the whole equation balanced. So I hope me working through this has helped you to understand this problem a little bit better. We did have to parse apart our polyatomic ion here because it only occurred on one side. If it did occur on both sides, then you could keep that polyatomic ion together when you balanced. That's all for now. Thank you for watching. Bye.